All right, so we're going to start with number 1, and then we're going to go to number 8. Number 1, we want to write a conjecture that describes the pattern. So we're going to put into words what this pattern is. And then we're going to use that conjecture to find the next term in the sequence. So first I have to identify what the pattern is. So on number 1, part A, what would you do to go from 1 to 3 that you could repeat, then to go from 3 to 5? Add 2. All right, so my conjecture is going to be add 2 to the previous term to get the next term. What is the next term in this sequence? 13. 11 plus 2. What is the pattern on part B? We're going from 2 to 4, and then 4 to 8, and then 8 to 16 times 2. So my conjecture here would be double or multiply by 2 the previous term to get the next term. What will the next term be? It's 64. The next term is 64. Okay. You're welcome. All right, we're going to go look at number 8 next. So many bars. All right, number 8 puts us right here. For number 8, we're trying to figure out what is the property or the theorem or the postulate that is being used to make this statement. So here's my statement. What is Ki? It's a segment. What is Ia? That's another segment. In the equation, what are we doing with those two segments? We are adding them. And then my last question on this one is, what is Ka? The whole segment. So Ka is another segment. So I have a segment plus a segment equals a segment. This would be segment addition postulate. What else would you guys like to see from the review? You said number 10? Absolutely. It says angles P and Q are supplementary. There's my if. So we're starting here. If I know that P and Q are supplementary, why would I be allowed to write an equation where they add up and equal 180? Definition of supplementary angles. That's what supplementary angles means. It means they add up to 180 degrees. Since we're right here, does anybody want to see number 9? You want to see number 9? All right, sounds good. This says the measurement of angle 1 is equal to the measurement of angle 3. That's these angles here. And then it says that the measurement of angle 2 is equal to the measurement of angle 4. This angle is congruent to this, or sorry, is equal measurement to that angle. What type of angles are 1 and 3, 2 and 4? They are vertical angles. So what could I use? Like just saying these are vertical angles, that would be the definition of vertical angles. Here I'm saying something about their relationship to each other. What allows me to talk about the relationship between vertical angles? Vertical angle theorem. Yes. Thank you. You're welcome. What else would you guys like to see from the review? Number 23? Absolutely. That's the next to last problem. Number 23 is one of the ones that we had to make a fix on yesterday. If you remember right, we had to add this very last statement here because it accidentally printed on the next page. Oops. All right, so let's walk through this proof. Where should I be getting my first statement from? It says the reason is given. Yes. Segment XY is congruent to segment WU. And segment XZ is congruent to segment ZU. I love it. That is all of this information right here. Let's go look at the picture. I want to mark the picture up with what we just said was given to us. So segment XY, that's this segment right here, is congruent to segment WU, this segment right here. And then segment XZ, that's this whole big long segment here, is congruent to segment ZU, which is this whole big long segment over here. What are we hoping to prove in the end? That YZ is congruent to ZW. These two little pieces I want to show are the same size. All right. So a couple things I notice. It gives me the next reason. It says definition of congruent segments. And the other thing I notice is in these last two statements that they give me, the next to last one has an equal sign in it. Do I have any equals yet? No. But I know these segments are congruent. What does it mean for the segments to be congruent? They're the same length. Their measurements are equal. That is the definition of what congruent segments are. So I can say the length of segment XY is equal to the length of segment WU. And the length of segment XZ is equal to the length of segment ZU. So far, so good? This third statement, technically speaking, I don't need any of the stuff above it to make this statement here. That is the segment addition postulate. We're saying that segment XZ, this segment right here, is made up of the measurements of XY put together with the measurement of YZ. Segment addition postulate. You're welcome. All right. I could have made that statement first if I wanted to, because that's based on the picture. I don't have to have the given information to make that statement. But now I need that statement because I'm going to use it. All right, so I'm looking still at what I'm trying to get to. Remember, I got to get here before I can go here. How many equations do I have in that next to last step? I have one equation down there. YZ equals ZW. So I want YZ, well, this is the first place in my proof where I see YZ. And I want ZW. This is the first place in my proof where I see ZW. Are those part of the same equation?
Oh, at the moment, no.
At the moment, no. They're part of two separate equations. Somehow I have to figure out how to get them in the same equation so that I can get one equal to the other. All right, so let's look. I know that XY plus YZ, this side of the equal sign, is the same size as what? XZ. So I could replace XZ in this equation right here from step 2 with XY plus YZ. Drop my equal sign down. Can I do another similar replacement? Yes, what can I replace? Yes, ZU is going to get replaced with ZW plus WU. That is my substitution property. It says I'm going to use the substitution property again now, though. All right, so again, I keep looking at where I'm trying to get to because that's my guidance. In the end, or next to last step rather, I want YZ, well here's YZ, and I want ZW, here's ZW. I've got some extra stuff though in that fourth statement. Yep, we're going to do a substitution here. What are the pieces that I want to get rid of? Like YZ is good, I want that to stay, and ZW is good. I want XY and WU to go away. How do we make things go away in math? Subtract them out. My subtraction property of equality would not work because they're not the same. It's not the same two letters. It's not the same segment. Tell me why I can do that. You're absolutely right. Why am I allowed to change XY to WU? Substitution property. So do we know that they're the same size? Yes. Right here, we said that they were the same size. So I'm going to replace the XY with WU. So WU plus YZ equals ZW plus WU. Could I have kept the XY and replaced the WU with an XY? Could I have done my replacement the other way? Yeah. They're congruent, they're the same size. We said they were equal. It doesn't matter which one I swap out for the other, as long as these two pieces end up the same. Mm-hmm. Now, how do I make them go away? Subtraction, property of equality. Are you allowed to abbreviate subtraction, property of equality? Yes. What abbreviation are you not allowed to use, though? SUB. Because if you write SUB, I don't know if you mean subtraction or substitution. You can write subtract, or even just SUBT, because that's different enough from substitution that I could figure out what you mean. But SUB, sub, isn't going to work. All right, we got one final step. We've gotten to the place where I can show that segment segment YZ, I don't know why I can't talk, segment YZ length is equal to the length of segment ZW. Why could I then make this leap and say that means the segments have to be congruent? Definition of congruent segments. Absolutely fantastic there. What else would you guys like to see? What other problems would you guys like to see? Yes. 21? Absolutely. Let's go look at problem number 21. Oh, this is a good one. I like this one a lot. It is numbers. It's also letters and pictures. Math has expanded. All right, so on number 21, it says using the figure to the right. So I'm looking at this picture. If the measure of angle LKJ is 137 degrees, I'm going to go mark that on my picture. Here's L, here's K, here's J. So when it says angle LKJ, it means this angle right here. That is 137 degrees. Says the measure of angle PKJ is x plus 5. P, back to K, and down to J. So this angle right here is x plus 5 degrees. And angle LKP, here's L, down to K, please stay focused, over to P, this angle here is x plus 90 degrees. I'm very sorry, sir. All right. What do they want me to find? The value of x and the measurement of angle LKP. So I'm going to have to write an equation here. Look at that picture. Be careful before you answer me. How many angles are in that picture? 3. What are those 3 angles? LKJ, JKP, and LKP. What do you notice about the relationship between those 3 angles? I'm sorry, one more time. I heard they're all equal to, and then I can't hear the rest of what you're saying, and I apologize. They're all equal to 137 degrees. Yes-ish, with a little caveat. Is angle JKP 137 degrees by itself? No. What'd you say? if we combine them, what operation would we use to combine these? Addition. So what are we going to need to use to do this problem? The angle addition postulate, because we're going to add angles together. If it asks for it. If it doesn't ask for it, then no. All right, so we're going to use the angle addition postulate to do this. The angle addition postulate lets me take two angles and add them together to get a third angle. What are the two angles that are going to be added together? Those are the measurements of them, which I will get to, but I want to know what are the angles, because angle addition postulate doesn't let me put those pieces in.
PKJ and
LKP. So PKJ together with LKP. When I put those two smaller angles together, I get what bigger angle? JKL or LKJ. Remember, when you're writing down an angle name, the middle letter has to stay put, but the first and the last letter are allowed to flip around. That's okay. So angle JKL is the same thing as LKJ. Now I can make my substitutions. What are we going to put in the place of angle PKJ? X plus 5. What did I just use there? Substitution. What goes in for LKP? X plus 90. And what goes in for LKJ? 137. Now we can solve this for X. We used angle addition postulate to be able to write an equation, and then we substituted our values into it. Do I have any like terms that I should combine together? The x's. And 5 and 90. So x plus x would give me 2x plus 95 equals 137. Now what? Subtract 95 from both sides. What is 137 minus 95? 42. So if 2x is 42, how big is just x? 21. X is 21. I still need what? Measurement of angle LKP, which was x plus 90. So to find the measurement of angle LKP, we're going to do 21 plus 90. What is 21 plus 90? 111. And then this question has a part B, and I actually already made you guys answer this part. What postulate, theorem, or property did you use to set up your equation? The angle addition postulate. What else would you guys like to see? We have a little less than 20 minutes, which is probably 3 problems. Number 6, absolutely. That is a fantastic problem. Number 7 as well. All right, let me go back to number 6. I should have enough time for both. All right. So number 6, parts A, B, and C, they want me to write the converse, the inverse, and the contrapositive. We had some keywords to help us remember how to do this. To do the converse, What do I do to my original conditional? Switch. So converse is switch. I need to switch my hypothesis and my conclusion. Here's the hypothesis. Everything after if, and everything after then is my conclusion. So instead of if two angles are a linear pair, this needs to be if what? Yep. If two angles are supplementary. I like that you guys replaced they with what we meant by they. If two angles are supplementary, then what? Yes, then they are a linear pair. All right, now we need to evaluate whether that is true or false. If two angles are supplementary, what does supplementary mean? Adding up to 180. If I have two angles that add up to 180, do they have to be a linear pair? No. Talk to me about a linear pair. Am I in your way?
They're like a pair with two adjacent sides.
Two adjacent angles, they share a side. So I can draw two angles that don't share a side. As long as they add up to 180, they're supplementary. Yes. So we're going to say this is a false statement. It says, if false, provide a counterexample. So I'm going to draw a picture for my counterexample. I need two angles that do not touch each other. So something like that. And I have to show somehow that they're supplementary here. I could say that one equals 80 and the other equals 100. Or I could do 30 and 150 or 20 and 160. As long as my numbers add up to 180, I'm good. So far, so good on part A? All right. Let's go look at part B then. In part B, we are going to write the inverse. What was our key word for inverse? Or words? Not. Inverse is not. We put a not with our hypothesis. And we put a not with our conclusion. And then I still have to write this all out. You can't just write in those little annotation marks and fix it that way. So I have to say, if two angles are not a linear pair, then they are not supplementary. And now we have to evaluate whether that is true or false. If I have two angles that do not form a linear pair, does that mean it's impossible for them to be supplementary? No, false. So I have to provide a counterexample. Will the counterexample that I used on part A work here? Yeah. Yes, so I can just recopy that exact same counterexample. I have an angle that's 80 degrees and an angle that's 100 degrees, and they are not a linear pair. Because they don't touch each other. I knew before we even wrote this one out that this was going to come out to be false. Because the converse and the inverse will always have the same truth value. So if the converse is false, the inverse has to be false. If the converse is true, the inverse has to be true. All right, we have our last one now, contrapositive. What's the key word or words for contrapositive? Yep, not switch or flip not. Not, and switch. So I want the not to come back in here. But now this is my new conclusion. Sorry, new hypothesis, because we're switching. My new hypothesis. And this is the new conclusion. So if what? If two angles are not supplementary, let me get that much written down, but you're absolutely right. If two angles are not supplementary, then what? Then they are not a linear pair. All right, let's determine the truth value on this. If I have two angles that do not add up to 180, could they form a linear pair? No. So this is a true statement. If they're not supplementary, they cannot be a linear pair. So it says, if true, explain how. So my explanation this time is linear pair angles always add to 180. And this is another one where I knew that this one was going to come out to be true before I even wrote it down. Because my original conditional statement and my contrapositive will always have the same truth value. And my original conditional statement, if two angles are a linear pair, then they are supplementary. That is a true statement. So if that's true, the contrapositive has to be true. If it's false, the contrapositive has to be false. All right, number 7 was the next one we were asked for. It says, write 3 true statements from the picture below. What's it showing us a picture of? A segment. So what can I use to help me write true statements here? So AB, BC, what do you want me to do with AB and BC? We can add them, and it would add up to give me what? AC. What else do we know about these segments? AB is congruent to BC. Well, if AB and BC are the same size, what would happen if I took the length of segment AB and I doubled it? That would give me AC. So 2 times the measurement of segment AB is the same size as segment AC. Or I could say 2 times BC is equal to AC. I want to write down just a couple more. BC is how much of AC? Half. BC is half of AC. What would I get if I took the length of segment AC and I subtracted off the length of segment AB? I would get the length of BC. All right, they asked us for 3. I gave 5. I think on my original answer key, I have something like 10. So there's a whole bunch of things we can say about this. Huh? What else would you guys like to see? I have time for probably 1, maybe 2 more problems if they're short. Which one, number 3? 20, yes, number 20. Write a 2-column proof to prove that x equals 58. Hold on just a second. I realized that I went past this one just a little too fast. And then we're going to go to number 20. All right, this is one of the ones that we had to fix yesterday. Remember, it put the little lines underneath for some reason. We had to move the segment lines up to the top. But what do I want to do with this information here? Goes on the statement side. So segment GH is congruent to segment JK. My reason? Given. There's another statement I can fill in right away. Yes, x equals 58. Where do I put that statement? All the way at the bottom. X equals 58. So there's a couple things that statement right there tells me. One, I'm going to need an equal sign. Do I have an equal sign right now? No. Can I get an equal sign from this information? Yes. What could I write down that has an equal sign? Definition of congruent segments would be my reason. So what does my statement look like? Length of segment GH equals the length of segment JK. I love it. We only have 2 more statements to make here. I know from looking down at where I'm trying to get to that I need something that has an X in it. Do you see anywhere that we've got X's? The picture. So what can I do with the picture? Substitute. What goes in for GH? 7x minus 13. What about for JK? Oh, 32. I'm sorry. I thought I heard 13 and I didn't look. That's my bad. 32. And JK? 6x plus 26. What did we use there? Substitution. Only one more statement. Now that I have an equation that has x's in it, what can I do? I can add 32 to both sides. Yes, you could also do that first. Okay, so that would give me 7x equals what? 6x plus 58. What did we just use there? The addition property of equality. Was that the only thing I could have done there? Did I have to add 32 to both sides next?
No, I could have subtracted 6 or 7.
I could have subtracted 6x or 7x from both sides. That would have been fine as well. I get to this step and I have to do what? I have to subtract 6x from both sides. And what are we using to do that? The subtraction property of equality. All right, we are less than 3 minutes from the bell, so I won't have time to do a whole nother problem, but I do want to show you guys on Canvas. I've already posted the answer key for this. So if you go on Canvas, once you click on modules, you're going to scroll down until you see today's date, Wednesday, 9/18. It says review for module 3A test, day 2. You're going to click on that. And you're going to scroll all the way to the bottom. Right down at the very bottom is where the answer key is for the test review. Right there. Also, I'm posting videos from every single class today. I've got first and second and third period already up. This period is going to go over here once it's done rendering. You guys can get in and watch these videos. I went over different questions in each class. All right? So you guys can get in there and check that out. Also, we'll be turning in your test review tomorrow. I count it for completion. You have access to the answer keys, so there's absolutely no reason why you should not get this completed. Please let me know if you guys have any questions tonight while you are studying. Send me messages in Canvas.